This video is going to talk about factors. A whole number is a number like 0, 1, 2, 3, 4, and so on. If we were to look at ways of getting two whole numbers to get to 12, we would use multiplication. 1 times 12 equals 12. 2 times 6 equals 12. 3 times 4 equals 12. The numbers that we're multiplying together are called the factors of 12. So the factors of 12 would be 1, 2, 3, 4, 6, and 12. So if we want to show that 2 is a factor of 6, we would show a multiplication sentence. 2 times 3 equals 6. There we go. We just showed that 2 is a factor of 6. We could also show 6 divided by 2 equals 3. Most times people are probably going to use multiplication. So if I want to write a multiplication equation that shows 5 as a factor of 10, I would multiply 5 times 2 to get 10. I would multiply 8 times 10 to get 80. 80. And I would multiply 10 times 23 to get to 30. If you're wondering how I got that so fast, don't forget that multiplying by 10 just adds a 0 to a number. We can also prove that 5 is a factor of 10 by skip counting. So if we count by 5s from 0, we can reach 10. 0, 5, 10. Same way we can count from 8s to get 80. 8, 16, 24, 32, eventually you're going to get 80. And we can count by 10s to reach 230. So let's write a multiplication that shows 1 as a factor of 2. Well, what times 1 equals 2? 1 times 2 equals 2. What times 1 equals 15? 1 times 15 equals 15. Multiplying by 1, you just multiply itself. We know this. So 1 is a factor of what numbers? Every number. So if I were to want to find the factors of 10, 0 times what equals 10? Nope. 1 times what equals 10? 1 times 2 equals 10. 2 times what equals 10? 2 times 5 equals 10. 3 times what equals 10? That one doesn't work. So when they were trying to find all the factors, they started at 0 and they went on. When we start at 0, 0 times anything is 0, so that's not going to work. So don't multiply by 0. We figured out what 1 times 2 equals 10. We figured out that 2 times 5 equals 10. We saw that 3 didn't work because 3 times 3 is 9 and 3 times 4 is 12. So if I want to find all the factors of 12, I would go ahead and I would start at 0. Can I multiply 0 by anything and get 12? No. Can I multiply 1 by anything and get 12? Yeah, 1 times 12. Can I multiply 2 by anything? That's a 2. Yes, 2 times 6. 3 times 4. Can I multiply by 5? By 4? Yes, I already got that there. Multiply by 5? No. 6? I already have that. 7? No. 8? No. 9? 10? 11? Nope. So the factors of 12 are 1, 2, 3, 4, 6, 12. To find the factors of 14, I know that 1 times 14 equals 14. I also know that 2 times 7 equals 14. Is there anything else? Nope. So the factors are 1, 2, 7, 14. 15. 1 times 15. 2 times something doesn't make 15. But I could do 3 times 5. So the factors of 15 are 1, 3, 5, and 15. So with these numbers, you can multiply these numbers times something to get the original. So all the factors of a number except for the number itself, seem to be quite a bit smaller than that number. Is there a number that is more than half of 18, other than 18 itself, that's going to be a factor? Let's go ahead and take a look. 1 is a factor. 2 is a factor because 2 times 9. 3 is a factor because 3 times 6. 4 is not a factor of 18. 5 is not. 6 is because 6 times 3. 7 is not. 8 is not. 9 is because 9 times 2. 10, 11, 12, 13, 14, 15, 16, 17, 18 is. And we can see here that nothing other than 18 itself is more than half of 18. Because we can multiply 3 times 6, 2 times 9, 1 times 18. We can make those same connections over here. 3 times 4, 2 times 6, 1 times 12. 2 times 7, 1 times 14. 3 into 5, 1 into 15. We already did that. So we could also do the same thing for 30. And we can know that 1 times 30. We can know that 2 times 15 equals 30. We know that 3 times 10 equals 30. 4s, 5s, 6s, 6s, 5s and 6s, and 5 times 6 equals 30. So we can start to see these patterns in here. So the factor of a number come in pairs. 3 times 4 equals 12, so 3 and 4 are a factor pair for 12. Remember that factor pairs can be reversed, 3 times 4 or 4 times 3. So let's look for the factors of 24. Can I multiply 1 times something and get 24? Yeah, 1 times 24. 2 times something? Sure, 2 times 12. 3 times something? 3 times 8. 4 times 6. 5. 6 times 4. 7. 8 times 3. 9. 10. 11. 12. 2 times 1. That's a 4. And 24 times 1. And we can continue to see that these are the exact same multiplication problems. Whoops. If we can draw the lines properly, we'll get there. These are the same multiplication problems. We don't need to list 1 times 24 if we have 24 times 1. Let's go ahead and look at factors of 28. So 1 times 28 equals 28, which means I don't need to worry about this. I know it's going to be 1. 2 times what equals 28? Well, 2 times 14, which means that 14 has to be 2. 3 times what equals 28? Nope. 4, no. 5, 6, 7 times 4 equals, whoops, remember that 4? 4 times 7, 7 times 4. Doing this is a great way to keep a double check for you so that you know that you've checked all of the numbers. Then we get to 40. We have 2 more. So I know that 1 times 40. So that would go all the way down to 40. I know that 2 times 20. So that would go all the way down to 2 right there. Those would connect up. I know that 4 times 10, or 10 times 4, so we're getting really close here. 5, I know that 5 times 8 is 40. And there we go. 6 and 7, 6 times 7 is 42. That doesn't work. Then we have 30. Excuse me, 36. 1 times 36 equals 36. So there's our first one. 2 times what equals 36? That would be, let's see, let's go ahead and do that division off to the side. 36 divided by 2. That would be 18. So I'm going to put 18 there. And oh, wow, look at that. There's an 18 down there. How convenient. 3 times what equals 36? That's going to be 3 times 12. we're going to go down to 12 and put a 3 in there. 4 times what equals 36? Well, that's 4 times 9, and that's 9 times 4. 5 into 36, 6 times 6 is 36, so that one just kind of hangs out and is right there. And we don't have to continue because we already have 4, 3, and there's nothing else we can do. So if we want to know whether or not 3 is a factor of 32, 3 is a factor of 42, and if it is, what it pairs with. So you can see that they started at 30 because we know that 3 times 10 is 30. 3 times 11 is 33. Times 12 is 36. Times 13 is 39. Times 14 is 42. And that's a way that we can count up by starting at something that we know, 3 times 10, and then building up 3 times 11, 3 times 12, just by adding that 3 every time. So they want us to use skip counting to answer each question. If the answer is yes, write the factor pair. You go ahead, give this a shot on your own, and when you come back, we'll talk about it. Welcome back. So, is 4 a factor of 32? Well, I know that 4 times 10 is 12, or 4 times 10 is 40. So I'm going to write times 10 equals 40. 11 is 44. 12 is 48, which must mean that 13, 4 times 13 is 52. Is 6 a factor of 92? Ooh. Well, I know that 6 times 10 equals 60. I know that 6 times 5 equals 30. So if I add those up, that makes 6 times 15, 90. So 6 is not a factor of 92. Is 7 a factor of 84? Well, I know that 7 times 11 is 77. And if I do times 12, that's going to get me to 84. So yes, we would multiply times 12. And is 8 a factor of 92? I know that 8 times 10 is 80. Times 11 is 88. And 88 plus 4 is 92, so that's going to be a no. 12 a factor of 160. That's an interesting one for you to try. To know whether 3 is a factor of 78, and if it is, what it pairs with, you can see they saw that 3 times 10 is 30, 3 times 20 is 60, 3 times 30 is 90. We know those, and we can see that the closest thing that we can get to 78 without going over is 60. We can also, by the way, fun fact, we can also test these by using the 3 multiplication rule, which is if you take the factors of 7 or the digits of 7 and 8 and add them up, 7 plus 8 is 15. So we know that 3 does go into 78 somehow because 15 can be divided by 3, so 78 can be divided by 3. So let's figure out how many times. So I know that 60, 3 times 20 is 60, times 21, adding another 3 would be 63, 66, 69, 72, 74, 75, 78, 20, 21, 22, 23, 24, 25. So that would be times 26. So go ahead and use skip counting to answer each of these questions. Is 3 a factor of 77? Well, back here we knew that just by following, we get to 78, not to 77. So that's a no. Is 4 a factor of 92? Well, I know that 4 times 20 is 80. And then we get 84, 88, 92. Yes, it is. So that's going to be 4 times, well, they want the 20, 21, 22, 4 times 23. Is 3 a factor of 99? Well, if I multiply 3 times 11, I get 33. 3 times 22 equals 66, and 3 times 33 equals 99. So yes, 3 times 33. And then we want to know if 4 is a factor of 86. So I know that 4 times 20 equals 80. And then I'd go 84 and then 88. So I would say no. So note that the ones digit of 3 times 6 should be the same as the ones digit for 3 times 26, because it's just 3. So we have 3 times 27 equals 3 times 20 plus 3 times 7. So we can do 3 times 20 is 60. 3 times 7 is 21. And if we had 60 plus 21, we would get 81. 27 times 3, let's test it out. 7 times 3 is 21. 3 times 2 is 6. 7, 8. 81. So go ahead and read through some of these tricks for eliminating factors. If the number is odd, no even number can be a factor. If the ones digit is anything other than 0 or 5, it can't be 5. And if the number isn't a factor, no multiple can be a factor. So if, for example, 2 isn't a factor, then 4 and 8 also can't be factors. So they want you to find all the pairs of numbers that multiply to 42. So I know that we have 1 times 42. I know that 42 can be divided by 2, and that would be 21. And I know that 42 can be divided by 3, because I know that 3 times 10 is 30. 3 times 11 is 33. 3 times 12 is 36. 3 times 13 is 39. And 3 times 14 is 21. Now, can 4 go into 42? No, I know that. 5? No. 6 into 42? Yes. 6 times 7. And because I've reached 6 times 7, I know the next factor is going to be 7 times 6. So I'm at the end. These are all the pairs of numbers that multiply into 42. Let's go ahead and do 72. I know 1 times 72. 72 is even, so I know it's going to be 2 times something. And while I know 72 divided by 2 would be 3, 6, that would be 36. So 2 times 36. I know that I can divide 72 by 3. So I know that 3 times 20 is 60. 3 times 21 is 63. 3 times 22 is 66. 3 times 23 is 69. And 3 times 24 is 72. Can't do 4s, can I? Let's go ahead and check those 4s. I know that 4 times 20 equals 80. That goes too far, so let's try subtracting. 80 minus 4, or 4 times 19, would be 76. And 4 times 18 minus another 4 would be 72. So I know that 4 times 18 it can create 72. Can 5 go? No. Can 6 go? Let's go ahead and take a look at 6. I know that 6 times 10 is 60. 6 times 11 is 66. 6 times 12 is 72. Can 7 go into 72? No. Can 8 go into 72? Sure. I know that 8 times 9 is 72. And I know that the next number is 9, and I know 9 times 8, so I'm done here also. Let's go ahead and make factor pairs for 63. I know that I'm going to do it over here so I have more room. 1 times 63. Can't multiply by 2. Can I do 3? Sure. 3 times 20 is 63, so 3 times 21 is 3 times 20 is 60, so 3 times 21 is 63. And then I go to 4. Well, it's not even, so no even number will go into it. 5, no. 6, no, because 6 times 10 is 63. 7, sure, I can do 7 times 9 and get 63. And since 8 doesn't work, I'm back over here at the 9 to go the other direction. So I'm done there. And then let's do 60. First thing, I know 1 times 60. 60 is even, so I know I can do 2 times 30. And then 3 times 20 is 60. 4 times, well, I know that 4 times 10 is 40. 4 times 10 is 40. And I know that 4 times 5 is 30. I'm sorry. What am I trying to say here? This is why you should write it down. I know that 4 times 10 equals 40. That's what I was going to do. Okay. And I know that 4 times 5 equals 20. So if I add up 40 plus 20, I get 60. So then I add up the 10 plus 5, and I get 15. 4 times 15 equals 60. I know that 5 times 6. I'm sorry. 5 times 12 equals 60. I'm like 2 steps ahead in my brain. I need to slow down a little bit. And then I know that 6 times 10 equals 60. 7 doesn't go in, 8 doesn't go in, 9 doesn't go in. So I'm at the end of my answers, just like I'm at the end of the slide. Ladies and gentlemen, I hope that you have a wonderful rest of the day.